Welcome to the UEFI Forum webinar. We will begin here shortly. Hello and welcome to the UEFI Forum webinar, EDK2-test, New Test Coverages and Future Roadmap, presented by ARM. Our presenter today is Edhaya Chandran, Chair of the UEFI Test Working Group and Staff Engineer at ARM. I'll turn it over to you to get this webinar started.
Thank you, Samantha. Thanks for the introduction. I welcome you all to this presentation and a very good morning. So let's look at the agenda for today. We are going to start off with an introduction to Tiano Core EDK2 test and UEFI-SCT. Then I will introduce the ARM specifications, BBR and BBSR. So this is the background to understand the new test coverages and improvements added, which is the next section. And under this, we are going to talk how ARM BBR and BBSR leverage the UEFI SCT and the latest coverages added. Then we will briefly see the improvements in the documentation of UEFI SCT and some improvements that is ongoing in the GitHub developer process. Then we will jump on to the EDK2 test future roadmap, and we'll talk about increasing more coverage with ARM BBR focus. And then we will see the new tests that will be added in UEFI Secure Boot and some general code quality improvements. Then I will end the presentation with a call for contribution. So let's move ahead. So the Tiano Core EDK2 test provides a test infrastructure for EDK2 based firmware, and it specifically focuses on testing and validating the functionality of components developed within the EDK2 environment. And we know that this is part of the Tiano Core project, which is open source and provides the reference implementation of UEFI. The EDK2 test project includes various sub-projects and components, such as the UEFI self-certification test, which ensures that the firmware implementations conform to the UEFI specifications. So the UEFI SCT is basically a collection of test suites, and it is modern, feature-rich, cross-platform firmware test environment. And it has a test harness for executing the built-in compliance tests. And it also provides scope for integrating user-defined tests. And it is built and run as an UEFI shell app. So just to show the availability of the EDK2 test. So this is open source and it is available within the GitHub Tiano Core project. And we have a detailed user guide which talks about the various configurations in which the SCT can be run. and also the various shell options possible. And we have the link to the releases that have happened. So far there have been three major tags and releases. And the builds are available for x64, IA32, ARM ARC64, and long ARC64 platforms. So just to give you a primer of the usage of the UEFI-SCT, so we have the basic options here. So sct.efi-a will execute all the tests, and sct.efi-c will continue the execution from where it left off, and sct.efi-r will reset the current test execution so that it can be run again. That is, it will clear all the logs and all the states. Then we have an interesting option, the sct.efi-u. So this will open a simple text-based GUI where we can configure the exact test cases that we want to run. So the screenshot in the left shows how this GUI looks. And here we have the various test suites. And in fact, we can go one level inside and choose the exact test suites that we want to run. So in this example, I have chosen to run a few, which is marked with X, and I have chosen to run one time each. So here, one point also to notice that during its execution, the UEFI-SCT may restart several times, and this is normal. So during this restart, it may test some features related to the non-volatile variables, or it may test the restart itself. And after each restart, it has mechanism to continue the test execution from where it left off. Yes, so now let's talk about the ARM BBR and BBSR specifications. So these come under the system specifications of ARM. So here, firstly about ARM base boot requirements, BBR. So this defines the base firmware requirements that standardize firmware and boot process for ARM A profile based system. And ARM BBR derives from the industry standards such as UEFI, ACPI, SMBIOS, device tree, and the TFA. So the BBR itself is organized as a set of recipes to accommodate various operating systems and hypervisors. So, for example, there is a recipe called SBBR, which focuses on ACPI based firmware and systems. So we also have some other recipes, EBBR, and so on. And each of these recipes define the boot and runtime services for a physical system, including the services for virtualization. And we also have the ARM base boot security requirement specification. So this defines the security requirements for the boot process on ARM based platform. And it is considered as an extension of BBR. It is still a firmware specification, and it defines requirements in UEFI authenticated variables, UEFI secure boot, capsule update, the TPM, and the measure boot related requirements. And we have the corresponding ACSs for each of the specification. So an ACS is ARM architecture compliance suite. So this provides an executable test coverage for a ARM system specification. So there are other specifications too, like the base system architecture and the SBMR. So each spec has a corresponding ACS, and it tests the rules of the specification, and it is used in the compliance test. Again, it will uh, it the each of the specification is rule based, and the ACS has tests to cover each rule stated, and to ensure that it is understood and implemented correctly. So the ARM BBR and BBSR ACS is also open sourced, and it is available in the ARM software space in GitHub, and it can be referred. And we have the detailed documentation of what these tests covers. The reason for introducing this is that the ARM ACS test leverage on the UEFI-SCT suite, and the development of ARM specifications and its evolution led to contribution in significant new test coverage and improvements in the UEFI-SCT. And for BBSR and BBR, ARM defines the UEFI-SCT sequence files. So if you remember the earlier screen in which there are all the tests listed, so the sequence files will pick and choose the tests needed, and we could configure the UEFI to cover the test cases in these two specifications. So the documentation of the sequence file is available for two recipes. So this can be referred, and it looks like uh, the screenshot on the right. So whatever tests are executed and selected will have the tick mark, and whatever is disabled will have the cross mark. So this provides a ready reference to know which recipes uh, in the BBR are uh, executed. So after that brief introduction, let's start about the new test coverage and improvements. So here are some concepts that will help to understand the coverages added. So the one is of the measure boot and the TPM. The measured boot is a security feature that records the state of firmware and software components during the boot process. And it uses the trusted platform module, the TPM, which is a security module to store the cryptographic measurements of each components. This is from the firmware up through the boot start drivers. And these measurements are stored in TPM's platform configuration register, that is the PCR, and can be used to verify the integrity of the boot process. So we have the TCG2 EFI protocol specification. So this is defined for 2.0, and the standard interfaces to TPM on a UEFI platform is defined. This includes the data structure and the APIs that allows the OS to interact with UEFI firmware to query information important in an early OS boot stage. So the ARM BBSR, as part of its requirement, covers a part of TCG2 protocol interface tests. And these were the tests that were implemented in the UEFI-SCT by ARM. And this includes the basic test infrastructure and the get capability test, the check for the headers with the TCG2 protocol definitions, the submit command, get active PCR, and some basic operation tests. And these tests are available in the EDK2 test upstream, and they are well documented with each scenarios and assertions in the UEFI-SCT test case spec. Read the docs. And these tests were extensively used in the compliance testing as part of the ARM system ready compliance program and have given good results and uncovered some live bugs. So now moving on to another concept of memory overwrite request. So there is the situation of the volatile memory decay. So this is when a platform reboots or shuts down. The contents of RAM are not immediately lost, but they begin to decay without an electric charge. And this provides an attack window for an attacker, so he can reboot the platform and dump the memory contents and compromise the encryption keys and other secrets. So to mitigate this, the platform firmware can initiate a system memory overwrite operation on the next reboot. So this memory overwrite should be done in a way that is unrelated to the existing memory contents. Generally, the system will zero the memory, and the platform firmware must complete the memory overwrite operation whenever signaled by the OS, though not necessarily on every reboot. So we need a mechanism for this, and this is already standardized. So this is an illustration of the concept itself. So here, the first case is where there is a normal OS shutdown. So we have a memory override request bit. So this, we will see how it is defined in UEFI in the coming slide. But we have a bit which is in the non-volatile space. And during the UEFI initialization, this bit is red. And since it is 0, there will be no operation of the clearing of the memory. And it goes on to the UEFI loader and loads the OS. And when there is a control shutdown, the OS will write 0 to this variable, that is to indicate that there is no need to clear the memory in the next reboot. And in the next reboot, again, the UEFI initialization checks this and it is 0, so it just continues with the OS boot. And the second case is where there is a abnormal OS shutdown, right? So it is, the shutdown is not as per procedure or it's not controlled. So in that case, the UEFI variable will still have the value 1, which is set by the UEFI loader. And in the next reboot, the UEFI initialization will check this bit, and reading it as 1, it will invoke a clear memory method to clear all uh, the previous contents. And then it will continue with the OS loading in the normal way. Right. So this is just for illustration purpose. It is not a uh, a I mean a fixed use case. This is to show that how this variable can come into play. So the mechanism is defined in the TCG PC client platform reset attack mitigation specification. And so we have a test of TCG memory overwrite in the SCT that was developed from this specification. So these tests confirm the functionality of memory overwrite request bit in the host platform non-volatile memory, and they also ensure that the platform firmware, bootloader, and OS use this bit to communicate effectively during the platform reset events. So the actual UEFI variable that is defined by the specification are two. So these are the memory override request control and the memory override request control lock. And these are defined in the chapter 4 of the specification. And ARM added tests for to exercise these variables and test their functionality. And this again is available in the EDK2 test tree for reference. And we also have the corresponding documentation. Let me also briefly talk about the improvement in the documentation itself. So now we have the UEFI-SCT test case spec documentation. So this has the detailed assertion for all the tests in UEFI-SCT in an easy to read tabular format. And this is a handy reference for debugging and maintenance and also for the new test developments. So this specification itself was donated by the UEFI forum to Tiano Core, and we updated for the latest tests and converted them to Markdown for integration and maintenance in GitHub. So we consider the Markdown as the code, and any changes can be done by the developer by the usual PR process. And then it is published online with every change on Read the Docs platform, and so that it is easy to access and available widely. So this is something that you have to check out offline. And we are also doing some updates in the GitHub developer process. So presently, EDK2 test follows the process of message list to submit the patches, including the review and the approval. So we are working on a mechanism to enable automated GitHub PR review and approval progress. So these are in lines with the automation developed for the EDK2 GitHub. And we are also doing some static code check cleanup of coverity report on EDK2 tests. So we have around, in total, around 1,000 warnings and errors, and we are now concentrating on the high priority 300 of them in the first phase. And the future plan is to develop an automatic code static check mechanism in the GitHub Actions. So with that, let me cover a, a bit of the future roadmap that we have in store for EDK2 and EDK2 test. So the one major activity that we are doing is to catch up with the UEFI specification. So there is presently a coverage gap in UEFI-SCT with the latest UEFI specification. So the UEFI-SCT presently supports the spec version 2.7 with some additional specific coverage that we talked about, that is the TCG2 and TPM tests. And presently we are doing the gap analysis of the test coverage between UEFI 2.7 to 2.11. So this includes checking all the ECRs that were implemented between these two versions. And ARM plans to develop the BBR and BBSR ACS focused UEFI requirements. So the contribution towards this effort and making the UEFI-SCT up to the latest spec are welcome. So I wish we get more developers and contribution for the other platforms, and there will be a call for this contribution formally. And as part of the ARM BBSR specification, there are also the UEFI secure boot tests. So these tests are already available in open source in the ARM BBR ACS space, and they are also well documented in the ACT case spec. And presently, we are working to customize and upstream them to EDK2 test. So we wanted to make a few test exercising more generic. And so this will be done in the coming days. And these tests have some very good coverage on UEFI authenticated variables and for platform reset attack prevention via PSCI, and the secure boot variable tests like set and reset of KEK, DB, and DBX, and also tests for the secure boot variables, attributes, and update. So with that, this is a call for contribution for the EDK2 code base. So this is a good starting point for anyone who wants to learn and familiarize with the EDK2 source. EDK2 test is a starting point, I should say, to learn the UEFI protocol interfaces and to be part of an active open source community. So I welcome all the budding developers to come in and contribute to this open source. And we have a monthly EDK2 bug triage meeting. So this happens every first Thursday of the month. And I have provided the link to the calendar here. So this is a place to meet other developers and see what is new, and of course, triaging the bugs that are online. And there is also a how to contribute page, and it will tell the mechanism for what the code review, the patch submissions, and so on. So this is something that the contributors can refer before starting off. So with that, I come to the end of the presentation. So any questions?
All right, it looks like we've received a question here. Our
Sure.
first question is UEFI-SCT the same as the ARM system ready on GitHub?
No, it is not the same. So UEFI-SCT is in the Tiano core space, and it was developed as part of the Tiano core project. And it is the official verification tool for the UEFI spec. Whereas the ARM system ready leverages the UEFI SCT and makes it part of its testing process. So we build UEFI SCT within the ARM system ready image, and we invoke it. And it is customized as per the ARM BBR specification, as I mentioned, through the sequence files. So I hope this answers the question.
All right, our next question here says, what is the duration of execution of UEFI-SCT?
Okay, that's a good question. So the answer is that it depends. So typically on a server, it may take around 4 to 5 hours. So the UEFI SCT is a very detailed test suite, and it changes according to the configuration of the system. So first it reads the system configuration, and based on the ACPI tables, depending on how many devices are there, so the test executions may vary. But it does take on an average 4 to 5 hours. And as I mentioned, there will be multiple restarts during this execution. So best is to leave it running overnight.
All right, our next question here is, can the UEFI SCT become a part of the EDK2 CI in the future?
I don't say it will become a part of EDK2 CI, but we are developing the CI for EDK2 test on the same lines. So they may be invoked differently, but it will have all the features that EDK2 test, EDK2 CI has.
All right, our next question here says, can the UEFI SCT tests be selected from the UEFI shell command line?
At present, it cannot be selected from the command line itself, but we can use the SCT minus U option to go into the GUI and select the exact test we want to run. We can even run a single test using this method, or we can choose the test suites that we would like to run.
All right, our next question here says, how do the tests in UEFI SCT differ from FWTS?
Okay, so UEFI SCT tests uh, the requirements in the UEFI spec, right? So SCT also tests some features of, uh, sorry, the FWTS also tests some features of UEFI, specifically the runtime features. However, FWTS has detailed tests for ACPI, device tree, and a few other features which are not fully tested in UEFI SCT. And FWTS runs after the OS boot. So it runs on the Ubuntu or a typical Linux. So it basically exercises the runtime variables of UEFI, and there are details tests for ACPI. Whereas the UEFI SCT runs on a pre-boot environment, so it has the opportunity to test the boot services of UEFI, for example, which cannot be done on FWTS. And FWTS is the uh, official test suite for the ACPI as declared by the UEFI tools page.
All right, our next question here is there an ETA on when SCT will use newer UEFI specification versions such as 2.10?
So presently there is no ETA. We are in the initial analysis of this process, and so we are lacking the effort to do this. So I would request more community involvement in this, because it is a huge task to be completed. And here from ARM, we are focusing on the requirement that will impact the BBR and BBSR specification. but it'll be great to see more participation.
All right. Our next question here says, what is Google Test and SCT?
Okay, I am not, I didn't get the question fully. Uh, Probably I can check this and reply offline to you, Richard.
Absolutely. All right here. So that's going to be all the time we have for questions today. We want to thank you again for joining today's UEFI Forum webinar.
Thank you, Samantha, for this opportunity, and thank you all for attending.
Thank you.